Okay, so what we just did in the last video is part C, step C, identify the significance level. So in this video, let's check for the requirements for normality. And again, we may skip over the drawing of the sketch, we'll see. And then we'll calculate the value of the test statistic. We'll show you how to calculate that and what a test statistic is. All right, so again, I'm going to go through here and try find where we left off at. I believe it's right here. Now, one thing I do in class, but since again we're not in class, we talk about type 1 and type 2 errors. We're going to skip over this, and if you see any questions on homework, practice, test, or quiz that deal with type 1 or type 2 error, you just skip them, okay? But, okay, I'm going to move ahead. I'm going to do this. So in order for us to be able to test a hypothesis, a hypothesized mean, we're going to use, again, try to use a t-distribution. Now, ladies and gentlemen, these requirements to be able to use that student t-distribution are, which is very similar to as the sample size gets larger than 30, it approaches a normal z-distribution, standard distribution. Otherwise, any less than 30, it's still bell-shaped unimodal, but remember, it's shorter and it's wider and it's wider and thicker at the tails than a normal distribution. So this is the same requirements as was with our comp symbol. The sample has to be a simple random sample, and either one or both of these conditions have to be satisfied. You either have to have it come from a population that is normally distributed, or your sample size has to be greater than or equal to 30. If you don't have a normal distributed population, a population that's unimodal and bell-shaped, then your sample size needs to be larger than 30. If your sample size is smaller than 30, and this happens sometimes, especially on small samples, and you don't know what shape the population is, go ahead and graph your data, however many you have, and as long as there's no outliers and it looks fairly uniform or unimodal and bell-shaped, again, it doesn't have to be strictly, bell-shaped, but as long as it looks like it doesn't have any outliers and it's somewhat uniform, then, or unimodal also, then we can go ahead and say that we believe the population at larger sizes sample size would probably be normal, okay? And we'll look at that on one of our examples, all right? So, now, I forgot I skipped ahead.
Christina Paulson, if you're in the building, if you could come to the office, please.
So, if we are going to use a t-distribution for a hypothesis test, then we have to look at something called the test statistic. The test statistic measures how far the sample statistic diverges or is away from what we expect the null hypothesis to be true. In essence, it's basically a z-score on a t-distribution. It's telling you how many standard deviations or standard errors away you are from what the null hypothesis is saying the value should be hypothesized to be. So, and it measures that in standardized units. So, the test statistic for any type of hypothesis test for any population parameter is equal to your statistical value minus the population parameter divided by the standard error, okay? For testing a hypothesis about the population, mean the test statistic will be found on a t-distribution as long as the requirements are met. You're going to take the sample mean you came up with minus the parameter. Now the parameter here is what comes from the null hypothesis. What's the value in the null hypothesis? What is the mean in this case, hypothesized to be equal to? And then you're going to divide that by your standard error, which is just the sample standard deviation divided by the square root of the sample size. Now again, what this will allow us to do is allow us to be able to find something called a probability value. And again, so this is something, I will put this on your formula sheet. You don't have to memorize it. But remember that for a t-distribution, you always use degrees of freedom, which means sample size minus 1. So again, this is your test statistic right here, ladies and gentlemen. That's what you want to use, okay? So we've already checked the requirements, and then I think I'm going to save this for the next video. We're going to start talking about, once you know your test statistic value, you can use it to help find something called a probability value. So that's what I'll use on the next slide, is we'll start talking about p-values, all right?